What's up, YouTube? So a fellow YouTuber asked me to do a welding video, and as a disclaimer, I am not a certified welder. A certified welder never taught me to weld, and basically I've just learned this from other mechanics and other people that I've met through my life. And do I do a great job at welding? No. Like, I'm not a great welder, but everything that I do weld stays together for years, and a lot of stuff has never ever cracked or come apart. So I'm going to show you the basics to welding and talk about some of the things that you need to do to ensure that you can get a good weld going. So what I've got set up here in my welder, I dug out a rusty old rotor and a brake pad, and I got a couple old rusty pipes. Sorry I don't have new clean metal, because I don't have any metal actually. I looked around, I've got some old metal over there, some more old metal over there, lots of scrap metal outside. So I figured, well, the brake rotor should be pretty simple to clean because it's just surface rust, and the same with the brake pad. So what I want to basically show you here is I've gotten that all cleaned up, and I'm going to try and basically weld the brake pad directly to the rotor just to show you a good bead going across there. You cannot weld through rust, you cannot weld through paint, you cannot weld through dirt. That stuff needs to be cleaned right down to bare metal in order to get good metal penetration. The reason why is the way that the welders actually work, and they basically work by transferring electrons, and they toss the metal going through. So if we call this our ground, or earth ground, and this metal lead coming out of the gun is going to be our positive charge. Now the leads could be reversed depending on whether you're using flux core wire, which the core of the wire actually has the shielding material inside of it, and to use MIG, you'd be using a metal inert gas, which would be hooked up to the machine, and the nozzle will actually let some of the gas come out as the welding's happening to get rid of contaminants and try and make a nice clean weld. So the idea is to have everything as clean as possible. If you have contaminants in where you're welding, whether it's just basically from the air or the surface material of what you're welding, you could end up with a contaminated weld, something that could crack prematurely, something that's weak, something that doesn't get very good penetration or has a lot of foreign material in it. So my welder's a pretty basic welder. As you can see, it has some voltage settings, but it doesn't have a variable voltage knob, which is kind of ideal for doing stuff, especially light stuff, because you can turn down the voltage just to where you need it, so that you're not blowing holes through material, but you're getting enough material down and it's actually penetrating. So this one does have a variable wire speed, and that will control the amount of wire, how fast it's coming out, in case you need extra material. If you notice you're making your weld and you're not getting a lot of material in there, you're going to want to raise the wire speed to get more of the welding material in there to make up for the gaps that you're going through cutting with the actual welder. So doing really light metal, you'll have to have the welder turned right down in voltage, and if you're doing something that's quite thick, you're going to need to turn the welder up. And usually on the inside of these little welders, they have a chart, and it basically tells you by what style wire you're using, or how big it is, and what gauge of metal you're trying to weld, and it'll tell you the settings that you should set the welder to in order to get a good weld going. Now for something like this thick, just this thick material, welding to the thickness of this brake pad, it wants me to put the voltage to max 2, which would be the highest setting, and I'm not probably going to do that. I'll probably have it on max 1 to give it the 3/4 setting, and I think that should be more than enough to get a good bead going in there. Now, welders basically work on the same principle as lightning hitting the ground from the sky. They just transfer metal along with it. So a lot of positive electrons are charged up, and they want to release themselves to ground. As that happens on the welder and you hit the trigger, it builds up with positive electrons, and it will start to arc on a little spark going right across and bridging a gap with the material coming off the end of the wire. And that will start to melt the material that's here and allow this material to mix in with it and begin actually filling the whole area. So this is where heat becomes very important. We need a lot of heat to penetrate that metal and make sure that mixture starts happening. Not enough, and it won't even start to happen. It'll just start to bubble on the surface of what you're trying to weld, and you're just left with little pieces that you can just knock away. So we need a lot of heat to penetrate what we're trying to weld. Now it'd be vice versa on this pipe. It's quite thin. We're not going to need a lot of heat to weld it, because it's just going to blow holes directly through that. Just imagine a little lightning bolt hitting that piece of metal, poof, it just blows a hole right through it. So you're going to have to turn it down lightly and have a lot of wire transfer in order to start stitching two small thin pieces of pipe together, which I'm going to show you. So like you've seen, I've got this brake rotor all cleaned up. The brake pad's cleaned up enough that we're going to make a weld there. We need a good surface to put our grounding clamp onto to make sure that we get decent electron flow going through here to weld. And the same with these two rusty pipes. You can see the inside of that. That's contamination. But I'm still going to try and weld it, because in the real world, we do this in the shop on people's cars and get them back together so that they can keep their $500 car instead of putting a $500 exhaust back on it. So stuff I like to have when I'm welding: possibly gloves, a little hammer, usually a welding hammer, but I don't have one, but I get this little baby hammer, so I use it. Clamps, flat-jawed clamps can do a lot for you. Bigger set than this is usually what you'd want to use, but that's what I have. A wire brush to clean up the surface area. If you stop welding and start again, you want to get rid of any contamination that's built up. And ventilation. You need a fan. Should probably open the back door, but I think I'll leave it as is, and I don't think it'll get too smoky. So yeah, I'm going to set the camera up here, and I'm going to basically explain to you what I'm going to do to make the weld, and then try and perform it. Camera's really not going to be able to pick it up. I do have like a little another mask that I could try and put on the camera, but I know that doesn't work very well, so I won't bother. I'll just try and explain to you what I'm going to do and then show you the results. Okay, so we're kind of set up here. I've got the brake rotor sitting at a good angle that the camera can see it and I can still weld on it. I've clamped the brake pad directly to the rotor. I have my ground clamp on the end there, and I have the welder set where I think it should be. It's about 3/4 the voltage, and the speed of the wires at 6. That's maybe a little bit high. I might turn it down a little bit because I don't have a lot to fill here. The idea when you're doing this type of weld, not that you'd be welding a brake pad to the rotor, because that'd be senseless, but you want to have a decent valley in between your weld area. So if this was a crack going directly straight across, which is unlikely but could happen, we'd want to grind this out to the point that there's quite a little gap down in there in between the two pieces of metal, so that as we're welding across, we want to try and take this little motion of sweeping back and forth in little semicircles. Is what I like to do. Some people just go one way and kind of lick it in there. Other people create a full circle. I've seen people do all kinds of things, but the semicircle usually is what will stack you dimes if you're trying to. So if we have quite a gap of metal in there, we're going to need the wire speed up quite high to fill that gap in. If we don't, we're going to be sitting there forever waiting for weld to go in. It's going to get hotter and hotter and hotter and start deforming the metal around it, and the weld's just going to go completely sloppy. And like I mentioned before, on the other hand, if we don't have enough voltage and the material's not getting hot enough, the material or the welding wire is actually going to start to bead on top of this metal. It's not going to penetrate it. It will bead on top of it, and it will stick to it, but not weld to it. So you can hit it and it will pop right off. So the idea is good penetration. You actually have to see this material begin to liquefy. As it is, you know that your wire's going into it, and as long as you have a nice surface here and you can actually see that you're building up material, you're good to go. And just continue filling in, filling in, filling in until you get quite far down. You need to stop for some reason, or you can just continue off to the end. So I really hope I got my camera set far enough behind my work area and it's up high enough, because I've already replaced one of these lenses due to probably grinder filings going off into the lens and actually melting into it. I think we're good to go here. So I'm going to put on some gloves. You do need some type of eye protection. There's no way you can do proper welding without it. Yes, you can just do spot and tacks without having it and having your eyes shut and not really watching what you're doing, blind weld. But if you're doing a proper weld, you need eye protection. So obviously I have a little bit more noise. I'll try and adjust my audio settings when I make the video, but I've got now the fan running behind us, and the welder does actually have a fan inside of it that runs and cools as well. So yeah, I'm not going to get into the pushing and pulling debate, because it's kind of pointless. There's times you're going to have to push. A lot of people like to pull. I like to pull. There's a certain way that you're heating the metal as you're laying down the material, and pulling seems to work best for me in most situations. So yeah, I'm going to start here at the top and just start kind of weaving it back and forth, and stop wherever I think. We'll have a look at it. So this first little bit, you can see I started to get the motion of what I need to do. There is too much material going down on here, and the wire speed should be turned down a little bit. It was good and hot, it was penetrating really well, but I didn't get really good penetration up here in the beginning, and it started to at the back here. So I want to turn down my wire speed just a little bit so I can sink a little bit more heat in there and lay the wire there just a little bit longer to get good penetration and continue through. Ultimately, you usually start with a lower setting and work your way up, but I was just kind of going on with the settings I thought should be there. So I'll just adjust the wire speed down to 5, and we'll try it there. So it's not the cleanest weld. I probably could have turned down the wire speed a little bit more, because the valley is not deep enough, and I'm not putting down enough material. I don't have enough missing material to add enough more material. But I mean, it's certainly welded. I know I could strike this with a hammer for quite a while until it breaks, and maybe I should try. So there's a couple of reasons that this broke. I didn't think it was going to, but I guess I was slugging it pretty hard. The quality of the rotors. I mean, this is just a porous, cheap material that loves to crack and break. If you've ever actually cracked a rotor trying to get it off a vehicle, it'll crack, and you can see it's quite porous material. It's really cheap metal. The other reason is I just didn't penetrate it far enough. The valley was not deep enough. I didn't get far enough in. I didn't lay enough material. But even still, with all of that, there's a good chance that might have still broken off because of the material I'm welding to. See, I guess my welding tutorial isn't going as well as I thought it would. I wanted to weld something and then hit it with a hammer and have it not break, but this is the real world. So yeah, just trying to imagine this piece of pipe is hanging in the car and we want to weld this piece of pipe to it. Ideally, this would overlap and we'd have extra material to heat up as we're welding, but you can butt joint them like this. It is possible. It makes a sloppier weld, but I've done tons of them, and it can be a little tricky. So you basically need to hold it by hand. You need to make sure the pipe's going to be as close as possible seam all the way around. And how I'm going to do that, I don't know. Something like that, I hope. And then I've got the welder turned down to the minimum voltage setting, and I've turned the wire speed all the way down to 3. I don't know how well this is going to go, but so yeah, I'm just going to try and put a little tack over on this side, maybe one over on the other side, and then run my beads afterwards. Now you can see I've got a good gap to fill in here. That's never a good thing. It's just an awful cut, and that's why it's sitting like that. You can see it's quite butted up all the way around, and there's just a little segment of metal in there that's not letting it actually seat properly, but you can fill it with wire. So we'll go ahead and try and fill this thing with weld without popping holes in it. All I'm going to do here is the same type of motion. I'm going to get those little semicircles going and just slowly try and pull it back to myself. I won't need a lot of material here. There is no valley to fill. I'm just trying to stitch this seam together. You don't want to get too hot. You will pop a hole and you will be there forever trying to fill that hole in. So you can see I've already popped a hole. We're trying to weld old rusted pipe. Like, it's thin to begin with. It's even thinner because it's rusted out a little bit. There's contamination everywhere. So we're just doing our best to stitch in this seam. And that's the type of thing that we're looking for. So now I've gotten to the portion of the pipe that's got the gap in it, and this is going to take some quick passing and possibly a little bit more wire to actually fill in. You do not want to start blowing a hole through this portion because it'll be more difficult to fill. It doesn't have a lot of material there to absorb the heat, so you have to be careful with overheating it. Try to turn down the voltage and see if that helps me. So as you can see, I mean, it's sloppily welded back together. It looks horrible, but it's definitely one-piece pipe again. It's not going to leak. You'd probably want to clean that up really good and apply some paint to it, try and not make it rust. But I probably should have bought some new pipe, at least had a couple pieces of new pipe and some new metal to show you some decent welding. Very difficult to weld rust, but you can see it is possible You can weld a rusted exhaust, like say you got a flange that's completely rotten off the end of a pipe. It is possible to weld that flange back to the pipe. It may not last forever, but it'll certainly get you by for maybe a year, maybe 2 years, depending on how long you want to keep that vehicle. Because an old rusted exhaust on a car, that car's old, and maybe you don't want to put a fortune of money into it. So yeah, it's a pretty horrible example of welding, but especially having one part break and the other just blow holes. But as you can see, you can weld stuff and you can get stuff back together even though it's old and rusted. It is possible to do it. If you have new materials that you're working with, it becomes a lot easier. Really thin metal, you will find a lot of times you just stitch it. You just put a couple little stitches just for a little second and then work onto another area because you don't want to get too hot. And that's still happening with this pipe, even though I adjusted the settings all the way down. And the same thing with doing body. Body generally has to be stitched on. You can't just start laying beads onto a fender or something like that. It doesn't work like that. But you need those tacks of metal on there to reinforce the two pieces of metal. And you may put lots of tacks along, but you cannot just go one straight line of bead. It'll never happen. The welders are not designed to do that type of metal. But yeah, depending if you like this video or not, give it a thumbs up or a thumbs down. If you haven't already, hit that subscribe button for me. Leave your questions and comments further down below, and I'll see you in the next one.